In the previous videos, we talked about how a hydrogen molecule can be formed from combining the two atomic orbitals from hydrogen atoms. So what we're going to start talking about, starting with this video, is how more complex molecules form, specifically organic molecules. So instead of focusing on hydrogen, for example, we're going to focus on carbon and the different types of hybridization that can exist around carbon and other atoms. So we're going to be focusing on carbon specifically. We'll start off with the electron configuration diagram for a carbon atom. So we have our electrons, we have 6 total in a carbon atom, and they are distributed in the orbitals going from the lowest energy orbital, which we said was the 1s orbital. The 1s atomic orbital is the lowest energy orbital. Then we said 2s was higher in energy than 1s, but not as high energy as the 2p orbitals. So we have our 1s, then our 2s, then our 3p orbitals. So these 3p orbitals here are going to be the X, Y, and Z orbitals that we saw in a few videos ago. So that's going to be at that second energy level. So we call it the 2p, but there are 3 of those orbitals, all degenerate, which means they're all the same energy. So what we have with this electron configuration of the carbon atom is that we have these 6 electrons distributed in the lowest energy orbitals that are possible. So we have 2 of those going into that 1s orbital, 2 going into the 2s orbital, and then the remaining 2 going in each individual p orbital, because we want to put electrons in their own orbital before putting them together if all the orbitals are the same energy. And so that's what we did for this. The valence electrons are the ones that are going to be important in bonding. So we're going to be talking about this second energy level. We say that carbon has 4 valence electrons, and we've used that for our Lewis structures, for example. What this is going to be important and kind of where those electrons are these 4 right here. So they're in that second energy level. These are the valence electrons. And we said there are 4 of them. So that's what those 4 are. These are going to be important when we talk about hybridization and then when we talk about bonding, because those are the electrons that are involved in bonding. They are the highest energy electrons in that carbon atom, and so that's where we're going to be focusing. So this full diagram doesn't really explain exactly what is observed for how carbon forms, the 4 bonds, and the observed angles. So what we're going to use instead to explain how carbon ends up forming 4 bonds at certain types of angles, depending on how many bonds or how many atoms it's attached to, we're going to be using hybridization of the atomic orbital. So they don't just bond the way they are like this. There's something that happens first, and that's going to be helping us to explain, and what exactly happens is going to explain how it bonds to other atoms, and also the shape with which it exhibits when it bonds to those other atoms. So that's what we're going to be using hybridization for. There are 3 different types of hybridization we're going to see for carbon atoms and also other atoms like oxygen and nitrogen, for example. For the carbon atoms, we have this electron configuration diagram just copied from the previous slide for carbon. What's going to happen for sp3 hybridization and all of the hybridizations, the first thing that is used to visually show what's going on is to say that one of these electrons gets promoted. It's a little bit of an energy jump, so these 2p's are a little bit higher in energy than the 2s orbitals, but this one, if it does that little jump, it gets to be in an orbital of its own. So that's what's the first step in the hybridization. Visually, we're showing that that one electron is now going to be in its own orbital. So now we have 4 orbitals in that second energy level, each with their own electron in it. But in order to make the bonds at the observed angles, we actually have to start combining some of these. So for sp3 hybridization, what that means is that this 1s orbital here in that second energy level, this orbital here is going to end up combining with all 3 p orbitals. So how we can show that, we can show just kind of a little dash line that these are all combining together. And what's going to happen? We're still going to have this 1s orbital down here. with its electrons. Nothing really happened with that one. This isn't the valence electrons, but somewhere in between the energy of the s and the p orbitals, it's going to kind of average out, and somewhere in the middle, we're going to have 4 new orbitals that are all going to be sp3 orbitals. So instead of having the one s orbital and then the 3 p-shaped orbitals, it's like we're taking all 4 of those, combining them into a blender, and then separating it out into 4 equal parts, but now they're combined orbitals, so they're the hybridized ones. So this will approximate about here. We're going to show the 4 of them. They each have 1 electron in it, and these are going to be our sp3 orbitals. And there are 4 of them because we put in the one orbital, that 2s orbital, 1 of those, and then 3 of the p. So that's going to give us 4 total orbitals out of it. These are all sp3 orbitals. We're going to see how they combine and what shape they make in the next video. For sp2 hybridization, we're doing something similar, except for we're taking, because it's sp2, we're only going to be taking 1 of the s's and 2 of the p's, which means we're going to have a p orbital left over at its original energy. So let's go ahead and draw what that would look like. So the 1s doesn't change. For the sp3 orbitals are going to be somewhere in between where the s and the p orbitals were. And then we're going to have just 1 p orbital that's going to be left over. So that's going to be one of those p's. They're going to all have an electron in them. And this time we're going to have 3 sp2 orbitals and 1 leftover p. So that leftover p orbital and this electron, that's going to be important for making pi bonds. So we're going to see that how they come together. And then these 3 sp2 orbitals are important for making sigma bonds. The last possibility, so what we did with the sp2, we actually just took 2 of the p's, so we combined the 1s with only 2 of the p's. For the sp orbitals, we're only taking 1s and 1 p, so we're going to just be taking those 2 orbitals together, and that's going to give us something that looks like this. So that 1s not being changed, we're going to have 2 sp orbitals, each with an electron in it. And then we're going to have 2 leftover p orbitals that didn't end up hybridizing. So those are going to be important for also for making pi bonds, but sp hybridized carbon is actually capable of making 2 pi bonds because it has 2 of the p orbitals to go and overlap with another atom's p orbitals. So we have this for hybridization. It's important to know kind of what we're getting out of this. So with sp3, you have all 4 of those orbitals that are left over are going to be all sp3 orbitals. For sp2, you're going to have 3 sp2 orbitals plus a leftover p orbital. For sp, you're going to have 2 sp orbitals plus 2 leftover p orbitals.